6 is all about factoring and solving quadratic equations. So we're going to start with 6.1 today, talking about the greatest common factor. So before we can do factoring with greatest common factor, we have to understand a few basic things. So we're going to refresh our math skills on. Okay, so your goal for today is to be able to factor out a greatest common factor. Okay, that is our goal today. Now, what is a factor in general? Just any factor. A factor is just a number or quantity, could be a variable, depending on your terms, okay, that when it's multiplied by another quantity or number, that it produces the given value or the given expression. Okay, so for instance, okay, if we're using just a number, let's say, let's go with 12. So if I have the number 12, there, whoa, hello. I don't know what just happened there. Okay, if I have the number 12, I want to know what the factors are. Okay, so the factors of 12, it could be 12 times 1. It could be 6 times 2. It could be 4 times 3. Do you all understand that? Those are all factors of 12. They're all numbers that when multiplied by another number would give you that number 12. Okay, so when we say factor, that's what we're talking about. Okay, so that's a list of factors of 12. Now, to factor an expression just means to rewrite it as a product of its factors. Okay, well, a product means to multiply. So in this example up above here, 12 times 1, I wrote those factors as a product. I'm multiplying 12 times 1, or 6 times 2, or 4 times 3. Okay, those are written as products. Okay, we list the factors as products. Now you can use a dot for multiplying. Okay, you could also use parentheses. So a lot of times it's written in this format with 2 sets of parentheses up against each other. So it could be 12 times 1, or it could be 6 times 2, or it could be 4 times 3. Okay, that's also ways to write the factors. Okay, you can use the dot or you can use parentheses. Now, when we're dealing with terms that have variables, they have letters, okay, most often we're going to use parentheses. Okay, so this example says what times what? See, there's a question mark in the 2 sets of parentheses. What 2 terms could I multiply to get 6x cubed? So you just have to break it down. There's more than one correct answer here because both of these are blank and unknown. Okay, so there's several possible answers. Okay, I'm not even going to write all the possible ones. Okay, but it could come out 6. What could multiply to give you 6? 6 times 1, or what else? 3 times 2. Okay, so 6 and 1 or 3 and 2 are possibilities for the number, the coefficient. But what about the variable, the x cubed? You have to remember our exponent rules. Okay, so remember when you multiply like bases and they have exponents, what do you do with those exponents? Who remembers from before Thanksgiving? This is one of the things that was on our test for Unit 5. You add them. Very good. So you would do A plus B. Okay. All right, so they're asking what could multiply together to give me x cubed? So that could be x times x squared, right? Or it could just be x squared times 1. So one of the possible factors, we said 6 and 1, and it could be x and x squared. So that's a possibility of factors. Or it could be, we said it could be 3 and 2. That would multiply to 6. Okay, and then it could be x cubed and then no x over here. So just 3x cubed and 2. Okay, those are not the only possibilities. There are lots of different, I'm just going to put ... because there's lots of possible variations of how you could break this down into two terms being multiplied that would give you this 6x squared. Okay, so you just want to make sure you understand that any two terms that multiply to give us, you know, our goal value, whatever it is, okay, those are factors. Okay, so let's try it. When they give us one of the factors, so instead of 2 blanks of what could be multiplied to give us this final product, only one of them is blank. One of them has a question mark. So we're multiplying this 6x squared y to the 7th times, times something, and we want it to equal 18x to the 4th y to the 8th. So I'm going to break this down. I'll try and color code it here for you. So I'm going to do the number. Okay, so 6 times what would give me 18? So I want to equal 18. 6 times what? 6 times 3. Somebody said it. So a 3. So there's going to be a 3 in this term. Then let's look at the x's. We've got x squared times something is going to equal x to the 4th. So we're trying to equal x to the 4th. We've got x squared. So what do we need to multiply that by to get x to the 4th? Remember the rule we reviewed up here said you add the powers. So 2 is going to be added to something to give me 4. 2 plus what gives me 4? 2. So this term needs to be x to the power of 2, or x squared. Okay, then I'll look at the y's. Okay, y to the 7th times something should give me y to the 8th. So I'm asking myself, y to the 7th times what would give me y to the 8th? Yeah, to the 1. I'm just going to write that a little neater. Okay, to turn that 7 into an 8, I need to add 1. So y to the first power. Now, if it's a first power, if it's a 1 as the exponent, do you actually have to write the 1? No, so I can just write y. So that is what that question mark factor here should have been. 3x squared y. That's what should fill in that blank. Is everybody good with that? These two multiplied together, the one that they gave us times what we came up with, would equal 18x to the 4th y to the 8th. Okay. I'm going to go over that green with a little darker green because I think maybe that's hard to see on the projector. A little better. All right, let's try it for number 2. Okay, so we've got a product over here where we know one of the factors. We want to know this other factor. When these are multiplied together, they equal this product. Okay, so I'm going to break it down again. So I want it to equal negative 30. It's going to be 5 times what? And you can write it to the side if you need to. If I want to equal negative 30, 5 times what would equal negative 30? Now, somebody said it, that's great. If you're struggling with the factors, if you're not great with your times table, what could I do to move this 5 to the other side to solve for this blank? What's the opposite of multiply? So I could just divide that 5 over, and that'll give it to me. I could do negative 30 divided by 5 to see what goes in this blank. So if you need to divide to figure out what goes in that blank, if you don't know it just off the top of your head, that's fine. You can do that division. You can solve for that blank. Okay, but that does come out to negative 6. So it's negative 6 for the number part, the coefficient. Okay, now let's look at the x's. I want it to equal x to the 5th. I've got x cubed, so what x term am I missing? I want to equal the power of 5, and I've got a power of 3. What's missing here? X squared. Because again, remember, they're being added. So x squared, because the 3 and the 2 would add to the 5. Good. All right, and then last but not least, the y's. I want y to the 6th. I've got a y, so what's the y that I'm missing? So I want y to the 6th. I've got y. What do I need to multiply that by? Y to the 5th. Very good. Because that's an understood 1, and the 1 plus 5 would equal the 6. So that's the factor that would go here in for this question mark. That's what I would need to multiply by to get that product here. So far, so good? Okay, so that's how you can, that's factors in general. Okay, what is a factor? These are factors, things that you multiply together to equal whatever this product is supposed to be. Okay, just like with numbers. Okay, the factors of 12 are 12 and 1, 6 and 2, 4 and 3. Those are all factors, things that could be multiplied together to get you back to that number or term. Now, when we talk about greatest common factor, okay, we're getting more specific here. Okay, it's not just any factor, it is the greatest common factor. Okay, often abbreviated as GCF, stands for greatest common factor. What does that word greatest mean? We're looking for the greatest, we're looking for the biggest or largest. So we want the biggest term that's a factor. A common, if you have something in common with someone, it's the same. You do it the same, right? So we want the biggest number that's the same for both terms in whatever we're factoring out of. Okay, so there's going to be multiple terms. We need to find a factor that they have in common, and we want the biggest one that they have in common. Okay, so the greatest number, so the biggest, if you want to write biggest in place of greatest, biggest number and or variable, sometimes we're dealing with x's and y's too, that would divide evenly. That means no decimals or fractions. Divides evenly, no decimals or fractions. Okay, from each of the terms. Okay, so for 6 and 8, what is the biggest number that I can divide both 6 and 8 by? Evenly. Divide evenly means I don't want a decimal or a fraction answer. What can I divide both of those by? If you don't know off the top of your head, you can list the factors. So what are the factors of 6? What numbers multiply to give you 6? 6 times 1 and 3 times 2. Okay, then the factors of 8, what do you multiply to get 8? You could do 8 times 1, or what else? 2 times 4, or 4 times 2. It doesn't matter what order you put it in. Okay, so those are the factors. Do these two lists have anything in common? They both have a 1. What else do they both have? They both have a 2. Which one's bigger, 1 or 2? 2. So 2 is the biggest or greatest factor that they have in common. Okay, so 2 is my GCF. Greatest common factor. Okay, what about in number 4 here? Now I'm not dealing with numbers or coefficients or constants. I'm dealing with variables. So we have to remember our exponent rules. When I have exponents, x to the 5th and x cubed, the greatest exponent that I can divide out of both of those is actually going to be the smallest exponent of the group. So I could divide both of these by x cubed, couldn't I? You'll see that? If I divide, remember the dividing, we said when you're multiplying like bases, you add the exponents. What do you do when you divide like bases? You subtract the exponents. Okay, so if I was doing that, that would leave me with, what in the heck? Come on. X to the 5th divided by x cubed would leave me with x squared, and x cubed divided by x cubed would leave me with 1, because anything divided by itself is 1, right? So did those both divide evenly by x cubed? I could divide that out of both. So that is my GCF. My GCF is x cubed. That's what I can divide out evenly. If it helps when you're dealing with variables, if you don't remember those exponent rules, you can write out how many x's there are here. Okay, if I have x to the 5th, that means I've got 5 x's being multiplied. And if I've got x cubed, that means I've got 3 x's being multiplied. Okay, so the most that I can take out of both is 3, right? I can't take away more than there are, can I? So 3 is the most. 3 is the highest exponent that can be taken out of both. So if that helps you understand, you're just looking for really the smallest exponent in these cases. So here, looking at those x's, there's an x squared and there's an x to the 5th. What's the maximum number of x's that you can take out of both of those? The 2, right? So x squared will be part of your GCF for this one. Okay, what about the y's? We've got y cubed and y squared. So what's the most number of y's you can take out of both? Y squared. And it's the smaller of the 2 exponents. So your GCF here, when you're dealing with the variables, is actually the smallest exponent that they both, for the base that they have in common. All right, now this one has numbers and variables, numbers and letters. So let's look at them separately. What can I divide out of both 16 and 20? What can they both be divided by? They can both be divided by 2. But is that the biggest number that they can both be divided by? They can both be divided by 4. 4 is bigger than 2. Is there anything bigger than 4 that they can both be divided by? I don't think so. This could be divided by 8, but 20 can't be. 20 can be divided by 5, but 16 can't be. So 4 is the biggest that they can both be divided by. So 4 is the number part of the GCF. Okay, but now let's look at the variable part, the m squared and m cubed. What's going to be the GCF for the variables? What's the most number of m's you can take out of both? The 2, right? So m squared. So 4m squared is your GCF, your greatest common factor. Okay, if you need to show the work like I did here for the variables, where you list out how many of them there are so you can see how many you can take out, or if you need to list the factors for your numbers like I did here so you can see what they have in common, that's fine. You can list out your factors. You can list out all your variables. That doesn't hurt anything. All right, now, if we are going to factor out the GCF from a polynomial, so it's not just a list of numbers or variables that we're finding the GCF of. If we are told factor a GCF from a polynomial expression, that means there's going to be pluses and minus signs. Okay, that means we're looking for what is the GCF. So we're going to find the GCF. Okay, and we're going to write that in front. We're going to write the GCF that we divide out of everything out in front. And then we're going to put the remainder in parentheses. What we're left with after we divide out that GCF. So we figure out what is the GCF and we divide it out and we write it out in front. And then we put in parentheses what we're left with after we divide. Okay. So for number 1, I've got 6x plus 24. So 6x and 24 are my 2 terms. So what can I divide out? I did not mean to highlight, sorry, underline. What can 6 and 24 both be divided by? They can be divided by 2, but is that the biggest number they can be divided by? If you're not sure, we can list the factors. 6. 24 is divisible by 6, isn't it? Okay, so, and 6 is definitely the biggest factor of 6. Okay, so 6 can be divided out of both. So I'm going to show dividing by 6. And I'm going to put that out in front. But what about the letters? Is there an X in both terms? No, the 24 doesn't have an X. So that means there is no X in the GCF. The GCF is just 6. So now I'm going to put in parentheses what's left when I do this division. Okay, so what is this 6 divided by 6 here? Isn't that 1? Anything divided by itself? So it's just 1x. So you don't have to write the 1, you can just write x. If you write 1x, that's okay. And then here we've got plus. What's 24 divided by 6? 4. So that is the remainder in parentheses. And that is the GCF out in front. So that's how we factor out the GCF. And this is my solution. This is how I write. This is the factored form of that polynomial. Okay, so back before Thanksgiving, we worked with polynomial operations. We multiplied. We know we could distribute this 6, right? We could multiply it by everything in the parentheses. It would get us back to what we started with. So factoring is going backward. Okay, we're dividing things out instead of multiplying them in. Okay, it's the reverse of what we were doing before. All right, now in number 2, we've got 3 terms. 8x cubed, 20x squared, 12x. So let's look at the numbers. 8, 20, and 12. What can be divided out of 8, 20, and 12? I heard something but couldn't quite. 4. Okay, so let's see. 8 can be divided by 4, 20 can be divided by 4, 12 can be divided by 4. The only thing bigger that 8 can be divided by is 8, right? Are 20 or 12 divisible by 8? No. So 4 is the biggest that we can divide out of all of these. So all of them are going to get 4 divided out of them. Now let's look at the letters, okay? This time, all the terms have an X, don't they? So I can factor out an X. What is, out of these 3 X terms, what's the lowest exponent? Yeah, this one, that's an understood 1, right? So that's the most that I can only take one. There's only one X there. So that's all I can take out of all of these is just X to the power of 1. Okay, so all of these are going to get divided by 4X. 4X is my GCF. Now I'm going to put in parentheses what's left when I do that division. Okay, so when I divide, what is here in the first term? 8 divided by 4. 2. And the x cubed divided by x. Remember, this is an understood power of 1 on these x's. So remember, you're subtracting. So x cubed divided by x to the 1, we're doing 3 minus 1. So what is that? X squared. Okay, now in the second term, first of all, that's a minus. What's 20 divided by 4? 5. And then what's x squared divided by x? Just x. You can put a power of 1 on it if you'd like, but you don't need it. And then you've got another minus. And then what's 12 divided by 4? 3. And then what's the x divided by x? Anything divided by itself? Yeah, it just, that reduces. It's a 1. And we already have a 3 there. 3 times 1 is still just 3. So that's not going to change. So that's my remainder, my leftovers, after I take out my GCF. So that is the factored form of that polynomial expression. Factored out the GCF of 4x, and then here's what we were left with. If we were to multiply that 4x back in, if we were to distribute it, it would get us back to this original polynomial. We feel okay about that, GCF? All right. Now, another type of factoring that we're going to look at that utilizes GCF is called grouping. If you have 4 terms and there is not a GCF among all 4, we can break it down and make it into 2 smaller groups. Okay, so for example, in number 1 here, I have 4 terms. There's nothing that can be divided out of all of these because the factors of 3, the only factor besides 1 would be 3. And these other terms are not divisible by 3, are they? And then the x's, there's an x in 3 of the terms, but this last one doesn't have an x. So I can't even factor out an x. There's nothing I can factor out. There's no GCF that they all 4 have in common. So I'm going to follow these steps up here that say we are going to create 2 groups. Okay, we're going to group the first 2 terms together in parentheses. And I like to color code mine. So I'm going to use purple around the first 2. Okay, so I'm grouping the first 2 terms in parentheses. And then let's do, we'll do this pink, the last 2 terms together. So I'll group those together. Now, within each of those groups separately, I'm going to find a GCF. So for the first group, the one in purple parentheses here, What do these two terms have in common? What can I divide both of them by? 3 what? 3 is the number, but look at your variables. They both have x, don't they? So I can factor out an x. So I'm going to put my GCF in front, and then in parentheses, what's left when I do that division. So 3 divided by 3, that's a 1. The x squared divided by x is x. And I've got a minus. And then 6 divided by 3 is 2. And those x's divide to just a 1. They reduce. So that's the GCF of the first group. Now I'm going to do the same thing with the second group. So 4 and 8 can both be divided by what? By 4. Now the thing is, we want our leftovers. What is remaining? We want it to, scroll over here. You should get a common binomial as the remainder. So here is my remainder of this first one. So when I do the GCF of this second one, I should get the same thing, x minus 2 again. But if I do negative 4 divided by 4, I'm going to get negative x. I don't want that. So I'm going to divide out that negative as part of my GCF. I'm going to divide out negative 4, which is going to leave me then with positive x, and then minus 2. Now those remainders match, don't they? They're both x minus 2. That's a good sign. Okay, you want that remainder to be the same. Now what that means is that that remainder is one of your factors. So x minus 2 is a factor, and then you group the two GCFs into one binomial as your other factor. So my two GCFs were 3x and negative 4. So I do 3x minus 4 as my other factor. And I have factored that by grouping. I'm going to try that one last time and we'll be done with our notes. So I'm going to group the first two terms together. 6x squared minus 3x. What can I divide out of both of those? 3, what? X again. 3x, same as the last one. Okay. So 3x can be divided out of both of those. What does that leave me with? What's 6 divided by 3? 2. And x squared divided by x is x. And then I've got a minus. What is 3x divided by 3x? No, anything divided by itself is 1. Both the 3's and the x's reduce. This is just a 1. There's no x anymore. Okay, now the second group, I want to end up with the same remainder, remember? So I want to change these signs again. There's no number that I can divide out, but I can divide out that negative 1 so that it makes me be left with positive 2x minus 1. Because the whole goal is you should get these two matching. So since those two match, 2x minus 1 is a factor. And then I bring together my GCFs. So 3x minus 1 is also a factor. So those are the two factors that if I were to multiply them back together would get me that original 4-term polynomial. All right, so I'm trying something different. I know last unit I gave y'all some Delta math practice on top of your worksheet. I'm not going to do worksheets this unit. We're going to try no worksheets. We're just going to use Delta math to practice. I think there's an advantage to you doing your work in Delta math because it immediately gives you your feedback. As soon as you answer a question, you know if you got it right or wrong. So remember, here is what it should look like for you. You have this assignment for 6.1. Okay, when you go to the questions, you have a show example button. You can see worked examples with the steps written out. Next example, so you can see several of those. You can watch a video to see how the problem is done. So you have help built into the problem types. Okay, you get 2 attempts at the question. So if you answer this and it's wrong, you'll get a little pop-up that says that's not right, go try again, and you'll get to try one more time. And if you get it right, great, you'll move on to the next question. But if you still have it wrong, it'll mark it wrong and you'll have to get a new question to attempt. You're not going to lose any points for getting it wrong, but you will have to do extra problems because the assignment is to get the set number completed. Okay, so in this case, there's 15. You want to get 15 of these right to get 100 on your grade. Okay, it may take you only 15 tries. Maybe you get them all right. Fantastic. It may take you 20. Maybe you'll get a handful wrong, and that's okay. Okay, but there's no penalty for getting them wrong. You just have to do some extra problems. Okay, but no worksheets. We're not going to do worksheets this unit. Just log into your Delta Math. You can use your Cat Tracks time. You can work outside of class. Okay, get your practice done.